Hi, and welcome to another session in the series of Unlocking the Value of System Center and Windows Azure Pack online with Microsoft and the Register. So this session is about deploying System Center in a matter of days. And we're going to show you how to take System Center, that really complex solution, how we can tame it and make it into an easier to deploy solution. So my name's Steve Beaumont. I'm an MVP within the System Center Cloud and Data Center Management space. I'm also the Product Development Director or Technical Director at POWERON Platforms. We're a relatively new company dealing with System Center, cloud automation and how we can actually deliver solutions differently. I have a Twitter handle at StevieBSC if you want to join me for some rambling thoughts, and I also blog on my own personal blog of systemcenter.ninja alongside our community of cloudos.com. I've also had the pleasure of writing some of the System Center cookbooks from Pack T, being the Service Manager Cookbook, or the Orchestrator Cookbook, and soon to be the Operations Manager Cookbook as well. So what will we cover today? Well, we're going to talk about what it takes to actually install System Center. So what's actually involved in terms of components, accounts, VMs, SQL instances. We'll go through all the different nuts and bolts of it. And in that, we'll actually talk about what comprises System Center as well. So you've seen Damien going through actually talking about some of the actual different components and how they fit together as the solution as a whole. And we'll break that down again a bit more granularly. We're also going to talk about how we can deploy and test System Center much quicker within your environments, how we can speed up the actual return on investment that you gain from it, as well as some of the other ways that you can now experience faster System Center delivery. So, as Damien was talking in the previous sessions, and of course the keynote this morning, around this whole vision of the Cloud OS and where System Center fits into it, we're looking at this different aspects of how we manage different solutions across both our private clouds and our public clouds in terms of Windows Azure, and how services like the Windows Intune and Office 365 can actually be used and utilized to help deliver your infrastructure, but with a consistent management platform that helps you manage, maintain and deploy across all these different areas. And that's where System Center fits nice and squarely. It's an on-premise solution branching out into the different areas such as your public service providers with extensions into things like Intune to help you deliver them services. So when we talk about System Center and when we actually come to start looking at put it in within our environments, some of the most common questions we start to ask is, well, how many products actually make up System Center 2012 R2? Well, this is actually a trick question. So the answer is actually one. So the product itself is System Center. Within System Center, we have them different components. And those were what Damien was going through earlier in terms of Data Protection Manager, Service Manager, Operations Manager. They're all the individual subcomponents that make up the product of System Center. So how long does it actually take to deploy out System Center? So all of them components that make up System Center. Well, it's far too long. It's quite simple. Most organizations will tend to pick one or two components. They typically tend to start with something like Operations Manager or Configuration Manager and get the very basics of some desktop or server management in. And then they really do have to then assess how much more they're going to have to spend in putting in the other components, because it's not a simple one-click task. In actual fact, how many screens when we go through doing an installation, including installing prerequisites and SQL Server, do we tend to actually see? Well, when it was counted up, there's actually over 500 plus, and it's more than that significantly now with the introduction of some of the things like Windows Azure Pack that we have to go through to actually get the basic installation and configuration done. And that's not including post-setup integrations. How many are there? Well, it depends on what's classed as a post-integration setup. It's kind of a cop-out question, but we're not talking about just integration features now where we might set up a connector from Service Manager into Operations Manager, but also around things like actually branching into using Intune in Configuration Manager, or deploying, connecting App Controller into Windows Azure so we can deploy VMs. There's far many more integration tasks after the setup that aren't possibly natively just into System Center these days, with things like the management pack for monitoring Office 365, where we have to do additional work to get that in. So when we take this complex product and we start to break it down, we have these various different components, and this was the state of play when it was first released. As we then move through to the SP1 and now the R2 release, we've got some additional extras that come under the orchestrator branding, which are things like the Service Provider Foundation, Service Reporting, or SMA or Service Management Automation. And these were all being introduced to actually help bring in the Windows Azure pack. So the Windows Azure pack interacts with things like the Service Provider Foundation to then branch out and interact with things like Virtual Machine Manager. So with all of these different components now in play, when we start to break down what's actually involved in each of them, each of these different components have different roles that are required. So quite sensibly, just about every single component needs a SQL database. It needs somewhere to store that configuration. So we have multiple different database requirements. Some of these can reside on the same instance. However, some of them have specific explicit requirements to make sure they are on dedicated SQL instances. For example, you're not going to share Operations Manager and Service Manager on the same instance, and you can't share the Service Manager Operational and Data Warehouse databases on the same instance. They obviously all have their own main management servers. So there is a dedicated server for Service Manager, for the management side of it, and for the data warehouse side. The same with Operations Manager has its management servers. Configuration Manager will have a primary site server, provider server. It's a similar concept, just different naming conventions. We get the idea. Each one has more than just a single server aspect to it. We have database servers, we have management and provider servers, we then introduce reporting sides of it, distribution points, content libraries, self-service portals. It's more than just an individual server to deploy System Center. So then we mentioned about the prerequisites. So when we come to deploy the actual prerequisites out for the estate, the vast majority of them are going to need some form of .NET and IIS. Not too bad. We can install that fairly quickly. We've got some server manager tools in 2012. We can add them. But then we add a few more. So we'll just add a few more. IIS.NET, maybe some Windows Update services for things like Configuration Manager or Virtual Machine Manager, add a few more of them on, a bit more .NET, and then we might as well add some SQL, and then we'll add some more SQL, and it goes on, and it goes on. There's report viewers to add into it, and then there's the SharePoint requirements if we're deploying the self-service portal for Service Manager. What I'm trying to stress here is there are a lot of prerequisites. Now obviously not every single server needs every single one of these. However, you'll find that the list doesn't drop down too much for just about all components. It's still a hefty, weighty list that you've got to remember to go through, install before starting the installation of System Center. Now all the installers will actually check these, and they will warn you if they're not installed, and then you can go back and reinstall them. But not many of the installers are actually going to do the work for you. So then we actually get around to actually being able to install System Center. So when we come to install System Center, the first thing that we have to do is define or design your deployment. This is not a product that you can just jump into, especially within a production environment, and just start clicking next, 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 and hope you'll have a really scalable, highly available, well-performing deployment. It just doesn't work like that. You need to take the time to sit down, analyze things of your estate, number of devices, network links, and actually decide how many VMs, how much sizing you're going to give them, memory, RAM, storage, how many SQL instances, where they're going to sit, the actual storage sublayer, before you start to do your deployments. Then you can go and download all them bits. So I'll put it in this order rather than going downloading the bits and then actually defining your deployment, because you want to actually understand which components of System Center you're going to be deploying, so you can go and download the correct bits. Once you've gone and got all the bits, then you can go and install each server OS. So create your VM, be it from a template, or even a physical machine if people still do that these days and age. But you have to get the OS ready, install it, make sure it's joined to the domain, create some service accounts, so each one of these products has their own bits. So SQL Server first stage, going to need some domain service accounts. Virtual Machine Manager, if you're going to install that in highly available mode, must be installed with a service account, and so forth. Log on to each server, install all them prerequisites we've listed. So all that big list, you need to make sure you've done your analysis as part of your defining your deployment, decided which server is going to house which component, to be able to take from that list and install the relevant prerequisites. You can then install SQL. You can grant your service accounts permissions so that it can actually access the SQL instance and be able to deploy databases to it. You can then install your first server role. So taking something like Operations Manager, you're going to deploy your first initial management server. Or Orchestrator, you're going to deploy your management role that creates the database connections and handles your integration pack deployment. You then install your additional roles, so things like self-service portals, any scale-out management servers that are required, or additional high availability nodes. You then go through granting each component the admin permissions, so making sure that you've logged into the servers and say, right, this group's is CM admins for config manager, SM admins for service manager. You then start to integrate them then, so you can actually set up the connectors from service manager into operations manager, so you can bring across the CIs into Active Directory, into virtual machine manager. Installing your consoles, so you can actually get the consoles out to your admin staff, so you can actually start to look at them. Connecting your consoles to the servers, so when you first launch a console, you actually have to specify the server that you want to connect to. Then you can deploy some agents, so you can actually get some data back into your environment. And finally, we can start to manage something. So this is what I'm saying, it was not a one-click process. We've not got a couple of servers deployed, a SQL server and a System Center server, where we click install and everything's magically done for us. There are a lot of steps to go through, and this is still oversimplifying it. Like you saw with that prerequisites list, you've got to do that analysis to find out which prerequisite is required by which component on which server that you're deploying. Not the easiest of tasks, and not something you're going to be doing one lunchtime. However, so the wonderful Rob Willis over at Microsoft actually decided to make our lives slightly easier. So he generated something called the PowerShell Deployment Toolkit, and this is available to download on the TechNet Gallery now via that link. The whole point of the PowerShell Deployment Toolkit is to make the installation of System Center for test environments easier. So it'll actually do half of the work for you in terms of actually deploying and downloading some of the components. So doing the installation with a PDT does become simpler. We still have that mandatory step where you have to define out what your deployment is going to look like. So you still have to do that decision aspect around where are these servers going to live, which hosts, how much memory am I going to allocate them, do I need to have extra resources, am I going to make SQL highly available, am I going to use all the components or am I just going to use some of them, what service accounts am I going to use. You have to do that design and defining exercise still. Then you can run the PDT downloader. This will go and get all of the different requirements for you, all them prerequisites, the System Center media, the SQL Server media will be downloaded and staged into a directory in a logical file structure ready for deployment. So we're saving that time of having to manually go off and find all the bits and download them. You can then run part of the PDT, which is the VM creator. So rather than having to go and sit in front of Hyper-V or VMM or vCenter and create lots of different VMs from templates and log them onto the domain, create them ready. This will do the task for you depending on them variables that you set. Still create some service accounts, make sure that we've got them defined within the variables, and then we can actually run the installer itself. So Rob has done a fantastic job of doing a lot of work around the workflow and the logic of which order components need to be installed in, what happens, which ones can sit on which servers and coexist happily, which ones must be on separate roles, once they're done in which order, how to integrate them, and it will do that installation routine for you. We can then install the agents, and then we can start to manage something. A lot easier to say, not so out of breath, a lot easier to see on screen, a lot quicker to deploy. So we've jumped from having lots and lots of different steps to do, lots of intelligence that had to be placed around how we did it, lots of thought process in terms of analysing which prerequisites went where, to a much easier step of doing the design work, doing the defining, and then being able to run a series of scripts to be able to actually do a lot of the hard work for us. So how do we actually define that deployment? So using the PowerShell deployment toolkit, we have this variable.xml file. In it, we can specify things like the global settings, things like user and company name, what is the actual account that we're going to use for the installation. So this is important because this is what it will use with things like PowerShell remoting to go to each of the individual machines and install things. Source path, obviously, because we need to tell it where all the files that we've downloaded, preferably using the PDT Toolkit downloader, to actually stage them ready for installation. And then we have the optional setting of actually telling it the product keys that we want to use for the various components. Now this is because primarily the PDT is probably used within test and lab environments, so it's just quicker to actually spin it up with a 30-day evaluation license, so we can try it, see what benefits it's going to give you, and then decide either later to license it or trash it down again. We get to specify settings for each individual component. Now most of the time this will be purely around things like which service accounts and passwords we're going to utilize for them, as well as the servers for each role. So this could be both the actual server that we want to use for the installation of things like the management servers or the self-service portals, the additional roles, but also the database roles must be specified, and they must specify the instance name that we're going to use for the individual components. And then we get to specify SQL settings for each instance. So do we want to use 2012, 2014 or even 2008? And what admin groups will we use for access to them as sysadmins within the roles? Now thankfully the installer file, the installer PS1 file for the PDT will actually validate all of these settings before the deployment. So if there are any misconfigurations, we should get warned without having to wait for a couple of hours for things to actually start installing or be finished installing. So now we're just going to take time to have a quick demo and look at things like the XML files for PDT and how we can actually use that downloader file to download the prerequisites for us. So you can see that I've downloaded the latest PowerShell deployment toolkit, currently at 2.6. We get these various files straight out the extraction of the zip. Now it's the variable XML file that we're most interested in. So if we have a quick look at this, we're just going to edit in Notepad. Here we can see that actually this contains all the main core raw settings for what we're going to set up as our deployment. So some of the things that we're going to see in here are things like the download location. So that's where we're going to actually download it from, and obviously we're going to reflect where we're going to install it from as well, so we're going to use the same path in both. Now the installer service account is obviously very important because that's where we're going to actually want to actually deploy it from, but also make sure that the domain that you specify is related to the domain that you're going to deploy it into. The components is obviously going to start to list out the various different settings for the different components. So we've got virtual machine manager there, provider, now orchestrator. And it's within here that we set the individual settings. For example, what admin group do we want to use for virtual machine manager? or the actual bits port, not that we generally change that. More importantly, things like the service count and password, which are going to be the most common stuff that you see within the different component settings. For example, provider framework below, it's mainly all service accounts and passwords. Now we can also scroll down and see the various other different bits, such as for every instance of SQL that we're going to be using, we can specify which individual server, as well along with the instance name and the version. And then we've got the individual component settings for SQL, such as what is the actual drive that we're going to be using for things like the tempdb and the user directory. And that goes on down for every single different SQL component, right through to where we start to see things like the VMs and their individual settings. So if we open it up in IE, it actually makes it a little bit easier to read. Obviously we can't edit it within here, but we can obviously subtract and see the different bits, such as the roles that we're going to be installing. So the downloader PowerShell script is the first one that we're going to utilize. So what we're going to do is we're going to actually have a look and install it into a folder on our D drive. So we saw from the XML file that it was going to install it to D installer. So if we launch an elevated PowerShell command window and then we execute the script, that will look for the variable XML file, or we can specify the individual path of where the files are going to reside. We can choose to do deployment only, which means it will only download the different individual components as specified in the variable XML file, and not just every component required. And then the get latest switch will just allow us, if we previously downloaded some bits, it'll only go off and get any updates that are required. So we're just going to run it without any command line switches, which will use the default variable XML file and then download any of the required components that we need. Now do be aware that it does require some extraction software, so if you run it without, then it will warn you that it needs either WinZip or 7-zip or something. The same, it also needs to make sure that it has WebPI installed first. So I have both of these installed, hence it being passed. It obviously goes off then and it will start to calculate how long it's going to take to download stuff. And as you can see, it's also going to tell us that a lot of this stuff is too big and must be downloaded manually. Once it's done its calculations, it will then start to actually download these files for us. Should start downloading them all to the installer folder. We see here it's already given us the folder structure nicely laid out, and now it's actually starting to do the initial download of content. So this is now pulling down the individual files of SQL, well, the ISO for SQL Server 2012. So we can actually start to see now that it's downloading these files. It's laid out the folder structure. We've got the different things like the Azure packs and the system centers at the root. Please note that it will actually download the System Center 2012 R2 and the SP1 files. But the main thing is that we've got the prerequisites that are all going to be downloaded, and as and when it sees whether it's an ISO file or a self-extracting XC, it will extract them into the relevant directories ready for installation. And then we'll end up with this complete set of files that can be utilized as part of the installer to do the deployment. Now obviously it's keeping track of where we are, how much it's downloaded and how long it's going to be before it's downloaded, and then at the end we'll get a lovely notification telling us how successful or unsuccessful it was of actually downloading the software ready for deployment. So now that we've actually looked at how we use that variable XML file, started to find out some of the sessions, and we can use it to download some of the content, it's a good time to talk about the actual VM Creator PowerShell script. So it is optional. You can use existing servers. They can be physical, virtual. They can actually be any virtualization platform. We have no requirements or mandates around that. We do, however, require that they be Windows Server. They have to be the minimum OS that is supported by the System Center component that you're installing. So that's going to be 2008 R2 most likely minimum. Preferably you're going to put them on 2012 R2, mainly because there's lots of benefits to doing that, and it is a more modern platform, and these are the type of systems and solutions that will be around for some considerable time. They've got to be domain joined. You can't install this lot on workgroup devices, and they must have WinRM enabled. So WinRM being that whole Windows remote management, hooking heavily into things like PowerShell remoting, make sure things like CredSSP is enabled for delegating fresh credentials, and quite obviously you must make sure that you have administrator permissions for the installer account on them existing VMs that you're going to be utilizing. However, if you're not using existing servers, you can use the VM creator to actually build out them virtual servers for you. So you need to obviously specify how many servers are within your deployment. So this again comes back to that defining and planning session. The VM creator was obviously going to start to do some analysis around this, make sure it's there, but you can install some system components on the same servers. However, it's recommended to make sure that each one's got its own dedicated. So count up the components that you're installing that make up System Center, and then obviously define how many VMs that you're going to be deploying. You can specify the defaults of which Hyper-V hosts you're going to be deploying these on, what the name is, how much memory, virtual CPUs, etc., which VLANs and stuff they're going to be living in, and more importantly, you can define all this lot, but you can override them for certain VMs. So for example, if you wanted your SQL servers sitting out on a different host, so that's one that's got more memories dedicated to it, you can have extra virtual memory allocated to them SQL servers, you can override them per VM within the actual variable files. And like I mentioned, this VM creator PowerShell script will validate all of the resources required for the creation, and then it goes on to actually create them virtual machines for you using a pre-staged VHDX file with the assist-prepped OS on it, joins it to the domain, enables the WinRM, again doing a lot of these prerequisite tasks that need to be done for you, as well as making sure that the installation account you're using for deployment has administrative rights to them servers. And then we get to actually do the fun bit. So the installer PowerShell script will do the deployment for you based on the settings you've defined within that variable XML file, utilizing the actual files that you downloaded using the downloader, and using potentially any VMs that you've deployed using the VM creator. So reducing the number of steps, doing the hard work for you, and then you get to sit and watch lovely progress bars as that deployment runs. Now there are going to be times where you need to do some more advanced configuration. So this starts by starting to move some of the variables from the workflow XML file into the actual variable XML file itself and specifying them. We can use existing SQL clusters. So if you are looking to use this more longer term than just a quick lab, and you have specific requirements from within your organization, from things like the SQL DB teams, then you can make sure you can use an existing SQL server that is set to your standards, but just make sure that things like the the installation service accounts have permissions to them existing SQL servers, because the scripts will not do any sort of validation against existing SQL infrastructure. If you're going to be looking around using SQL, then you need to make sure that it is right. So this is things like not just taking the default parameters and having just SQL installed to the C drive and all the database and log files mixed in on that. Giving it the chance to actually make sure that files are separated away. You have dedicated high performance drives for the right components with log files and databases separately, and your tempDB files, making sure that they're sized correctly, so doing any pre-sizing of database files, making sure that you have the multiple files if you're going to split it out according to how many CPUs and ratios, etc. But it is important to note that System Center lives or dies on its performance based on the SQL underlying infrastructure. So it's extremely important to get that right. Now we can utilize SQL clusters for high availability and failover, and the PowerShell deployment toolkit will create them SQL clusters for you but you must make sure that the VMs and the Windows cluster and any storage that's going to be utilized is there and created and ready available before you start to do the deployments. So this will need creating, staging, putting in as variables within the actual variable XML file so that it's ready for when you run the installer. And again, similarly with Virtual Machine Manager, because it's one of the other components that actually utilizes Windows clustering for high availability, you must again have that Windows cluster ready. So we're not talking about the VMM or the SQL clusters. That can be handled and created as part of the deployment. We're talking about the raw core Windows clustering service. And again, similarly with the Active Directory container, that you must make sure that you've got permissions for that before the actual deployment starts. And then as with advanced configurations, we start to look at scaling it out. So we don't have just the one server for Service Manager or Operations Manager. We actually have multiple servers, both for the high availability aspect, but also for the scale aspect. So for Service Manager, the number of concurrent consoles has a heavy impact, so we'll give additional management servers for consoles to connect to. Similarly with Operations Manager, we might want dedicated management servers in a resource pool just for network monitoring. So we look at deploying out the first initial roles and then scaling it out with additional, and they can be either done concurrently or sequentially on the script depending on which order that they are able to be deployed in. So like I mentioned, the PowerShell Deployment Toolkit is available on TechNet Gallery. Heavily recommend you search, go grab it, give it a test. You can run this on an individual laptop with enough memory and just try some of the components, get an idea for the look and feel of it. Obviously the more resources you throw at it, the more you can fit on there. And it's also heavily documented through the Microsoft Building Clouds blog. So Rob Willis spends his time, so if you go to that aka.ms, get to know PDT, you'll see where he introduces different scenarios and usage patterns, any tweaks that he adds to the different scripts and how it's evolved, and some of the different settings and how to configure them. Now, if you're not actually a PowerShell scripting king, I'll come on to how we can actually make that easier for you in a second. But it is strong to note that while the deployment toolkit can help speed up the deployment of System Center, it is not designed to replace some of the core functionality that actually System Center itself gives you. So it doesn't replace things like Configuration Manager software distribution. Yes, we're deploying software to servers, but it's not the same as using Config Manager to distribute software with all that reporting mechanisms, the available to do remediation and feedback of how it's going and minimize bandwidth and caching. In the same way, it's not designed to replace Virtual Machine Manager for actually creating the virtual machines themselves. The VM Creator PowerShell script will just create basic Hyper-V machines directly through Hyper-V PowerShell commandlets on Hyper-V hosts, whereas the Virtual Machine Manager is more heavily templatized, gives you the ability for further ongoing management and setting more advanced functionalities such as on a clustered server, things like availability sets. And it's even more important to say that it doesn't replace another type of deployment technology that could be used for any type of application and even System Center to that respect, which is the Virtual Machine Manager service templates. So this is used for service deployment and servicing. After all, System Center is a service to your business, an application business service, and it could be utilized for deploying it. Now I mentioned if you're not a PowerShell scripting king, even though it's getting more and more important in this day and age to actually learn PowerShell, take the time to understand it, look at resources like the books of Learn PowerShell in a month of lunches. If you're still in the GUI world, or you just want to utilize this to make it very quick to look at the PowerShell deployment toolkit and see how it can benefit yourselves, then there is a community effort now released on the TechNet Gallery that can actually give you a graphical user interface to the PDT to make it a lot easier than digging into the XML files for configuring variables, understanding what relates to what. So this was actually introduced by an MVP, Benedict Berger, and his colleague Kamil Kozek. Now they've done a fantastic effort, and this is where the MVPs and the community at large do shine and what they can offer back. So this, like I said, allows for much easier editing of the variables, to help you with your configuration for utilizing the PDT. And again, this can be downloaded from the TechNet gallery now. So we're actually going to take a quick look and see what the main difference is and how easier it is to use this to actually get a much quicker head start in deploying System Center. So I've downloaded the PDT toolkit to this server and the PDT GUI. We see earlier we've got the files that we've downloaded from the actual downloader side of the PDT toolkit, and now within the PDT GUI I have the actual script itself, plus it has downloaded the various PDT toolkit into the same folder because I've run it once already. That happens on the first run. If I launch PowerShell as an administrator, so make sure that the PDT toolkit GUI is run elevated. Obviously, when you do come to run it, make sure that your execution policy actually allows for running of scripts. Or unblock it, full stop. So obviously when you download any sort of file from the internet, it knows that it's not from a trusted site. You need to unblock it first, or set your PowerShell policy to even less secure than remote signed. And here we have the PDT GUI. So this is still utilizing the PDT as a raw deployment engine. This is just giving you a nice display to help you edit that XML file, the variable XML file, to help you deploy it. Now we can either use some of the ones that are within the actual installation folder itself, so we can see that we have these ones in the various different folders, and they've quite kindly given us different scenarios, whether we want to deploy just the Windows Azure pack or whether we want to deploy the actual full lot with the Azure pack or without it. Or we can actually go and find an actual deployment file ourselves. So I'll choose the one that's there in the base install. Straight away it starts to give us the configuration. It will show us the defaults that are stored within the file. It will also tell us any warnings graphically of where we haven't specified certain options. I'm going to ignore specifying the product keys because, as mentioned earlier, this can be done in a trial installation. We know where the actual source file for the installation is going to be, so this is on my D drive in the installer file, and then what our registered organizations are going to be called. We have the ability to then start deploying out the VMs or specifying what the VMs and types are going to be. So like I mentioned earlier, we have the default settings for the VM creator script, where we can actually choose the different hosts and the folders that they're going to be stored in, as well as actually defining out individual settings for individual virtual machines. We get all the config around our SQL servers that are going to be used in deployments, and the individual roles that we're going to be installing. So for this example, we can actually see which servers and which instances that we're going to be utilizing for the different aspects of Operations Manager, and the different components and their settings and their different roles. So this gives us the ability to very easily go through, choose the different options rather than editing the XML file itself, and when we're ready we can actually then kick off the various different components of the PDT toolkit. So we saw earlier where I did the actual downloader to create that installation source. We talked earlier around the VM creator role for creating them VMs on a Hyper-V host, as well as the installer for when we're actually ready to deploy out System Center. Now every chance that if I just run the validation process this will fail. Or the XML file I've chosen could actually be rather good. So all this is doing is going through that XML file, making sure that we haven't done any weird combinations and trying to put Service Manager on the Operations Manager server, for example, making sure that we have got accounts specified for where we're actually using them for service accounts, as well as making sure that the actual files that we, or making sure that the roles that we want to install actually have the files downloaded and ready and waiting for us. So rather than sitting and waiting and watching it just validating media depending on the speed of the disk, I'm just going to fast forward this slightly. So we can see straight away that I haven't actually got all of the files downloaded. So when we ran that downloader script right at the beginning, it did actually throw up a warning letting us know that certain files were bigger than what it was prepared to download. And then this has obviously highlighted that fact. So a good example of how making sure that you have a quick validation before deployment would save you a lot of time. So this is the PDT GUI. Not an overly complex tool, but that is where it has its whole benefits in its simplicity of taking it away from having to analyze lots and lots of XML files. So again, if we look in this, it would be a case of going through, doing the assessment, trying to work out which variables we needed to set, which ones we didn't, which ones we could take out, remove, which ones had to be there, into a much easier to understand GUI interface where we can quickly flick through the different tabs, configure the different options for the various different roles and components, and then just actually launch the installation from a single interface. So now that we've actually had a look at how the PDT hangs together and how we can use the GUI to actually enhance editing them XML files, again speeding up the process of being able to deliver System Center by making it a lot easier to understand and utilize, take out some of that hard knowledge that we have to know about how the different components integrate, interact and where they sit. It still hasn't removed that ability to have to sit down and do the definition or the design phase. It's still important to understand how it's going to be utilized, where it's going to be utilized, decisions around things like the actual resources required to run it, to make sure it's scaled properly, that it performs, and also about where it's actually going to live. Do you put it within your production infrastructure clusters? What happens then if something goes wrong, or do you have it, as the best practices recommend, in a dedicated fabric management layer somewhere? So Microsoft made a slight step to try and look at how they can address this, and they announced something called the actual cloud platform system. So this is slightly different than an offering of giving you the full System Center. This is about taking some of their learnings based on their public cloud learnings with Azure and bringing that in-house. So it actually helps you now deliver an Azure consistent look and feel infrastructure into your environment. So they do this by having a hardware platform where they heavily control what components are within there, what lengths of cables, for example, firmware revisions, and they know all the different interactions from the bare metal right through to the software. So this is backed and supported by Microsoft and the Premier support, and they do a lot of the orchestration around the updates and how that interacts on their timescales. And then they have a lot of optimized runbooks for automation on top of it for deploying Microsoft services such as things like Exchange and Active Directory and SharePoint. So what they're actually looking at doing with this is actually using that hardware base that they have now heavily defined with the partner DELL, having the actual load balancing, having the fault tolerance there from a hardware perspective, and then utilizing the Cloud OS stack to build on top of it. So we're bringing in the features of the Windows Server 2012 R2 platform, things like storage spaces to actually make the best of that JBOD commodity hardware level storage, ruling out configurations like RAID and utilizing the inbuilt software aspects of the Cloud OS or Windows Server, bringing in Hyper-V from the virtualization platform layer, using network virtualization to have that multi-tenancy aspect within your environment. And then they build on that with the management stacks of System Center, so enabling the control and the management of this new platform with Virtual Machine Manager, Operations Manager for monitoring. And then layering on Windows Azure Pack on top of that to actually give you that self-service experience, both from the administrator point of view, defining out plans for your tenants to be able to access, defining out the capacity that they actually utilize, and then from a tenant perspective, with different teams within your organization, or as a service provider, your external customers being able to deploy their own resources within that, but still having the capabilities of System Center to give you that whole idea of the monitoring aspect, being able to see the utilization, to do reports, to do scalability reviews on it. Now this hardware platform comes in a minimum of 1 rack, and then it can scale out to 4 racks. Now these are not little things. These are heavily configured, hugely converged, high performance infrastructure. These are not something you just drop in because you want a bit of System Center. These are where you bring in from either a massive data center expansion layer or from a greenfield perspective to be able to actually bring across the learnings and benefits of that Azure platform to give you that consistent look and feel of the CloudOS platform in your environment, but removing all of that hard work and knowledge and understanding of how you deliver that, because Microsoft do it to their best practices and recommendations, and then they continue to support this from their side. Now this has got some very heavy kit within it. We have networking in there, 10 gig Ethernet, we've got high performance compute scale units, and then we have lots and lots of storage. But as I said before, this is utilizing all the bits and features that are within the Server 2012 in terms of things like storage spaces and tiered storage spaces, utilizing things like the JBODs and the actual SSDs and the actual hard drive tiers to give you that performance aspect. But obviously all this lot comes at a cost, but it gives you some of the benefits of Azure Pack, or gives you all the benefits of Azure Pack out of the box. So if you really didn't want to wait, this can be dropped within the data center, powered up by Microsoft, and utilizing it almost straight away. So in addition to Microsoft have that offering around the cloud platform system, there's also another offering that's on the market for delivering System Center in a completely new and very fast automated fashion. And that's something from ourselves at POWERON Platforms. So we have a range of different solutions, building up right from individual components. So picking and choosing, almost like a la carte from a menu that you might want a bit of SCOM or a bit of config manager, and being able to rapidly deploy them into your environment on your existing infrastructure. So these are designed for us to do very heavy design work, understand how it fits within your environment, and then be able to deploy and deliver these fully configured, integrated with other System Center components, and extended out the box, not just a rapid deployment like the PowerShell deployment toolkit, but ready for production use very rapidly. We then build on top of that and go down the actual appliance physical hardware route, breaking it down into both the Azure Simple side. So this is combining the different elements of the Windows Azure Pack with things like service management automation, operations manager for monitoring, and virtual machine manager for deployment into that Azure Simple appliance, giving you that consistent look and feel of Azure for managing your environment, but also taking on the integration and the management of your existing infrastructure. This isn't limited to any greenfield deployments or new hardware. This is about taking control of your existing infrastructure and managing it in a more cloud-centric model. And then we have the integrated ITSM, so building on the benefits of your core infrastructure improvements, and actually then how do we develop and deploy things like your service desk using Service Manager, automation elements coming in from Orchestrator, and also that management of the desktop estate through Config Manager. And then above all these sits what we class as our top level appliance, which is the Cloud Management Appliance. So this Cloud Management Appliance can be extended, as can the other two appliances, with all the third-party extensions that you see within the industry, such as Searson bringing in that much richer ITSM experience within Service Manager, with very customer-focused self-service portals, very easy to use, and bridging the gaps with different components. and then things like Blue Stripe, enhancing SCOM for the application delivery, Veeam building on the monitoring and management of any VMware infrastructure because it's about hybrid private cloud management. But that cloud management appliance actually still helps you deliver System Center in that manner of days with a capability-led focus. And this is where we change the game slightly. Rather than worrying about the actual deployment methodology, there's no inherent value in doing the deployment on clicking and understanding which servers have got which components on. So having that removed and from a hardware appliance allows us to start looking at where the actual infrastructure sits and lives, what do you have to manage and maintain, what your end users are utilizing, how are they accessing things, introducing all this bring your own device, work anywhere scenarios. But having a very strong focus on the self-service aspect, be that through the things like the Windows Azure pack from a service provider type approach, right through to the service manager with your service catalog and configuration manager for application deployment. Having that bundled into your service model, delivering out your service catalog, and actually having the automation processes behind it supported by Orchestrator and Service Manager allows you to concentrate then on actually how you help provision and configure your environment and monitor and operate it in a life cycle approach, utilizing the full range of the System Center components. So this is moving away from delivering one or two in a very rapid fashion to actually having the entire stack of components within that product that is System Center that you have access to across all the different functional capabilities delivered as a hardware cloud management appliance rapidly into your infrastructure so you can start to utilize the consoles as an IT pro to gain the benefits of your estate and extend it into the likes of Windows Azure, Microsoft Intune, as soon as you have this within your environment. No long lead up times, because it is a cloud management appliance, fully configured on a hardware, highly available across both hardware and software layers, built to the Microsoft reference architecture, meaning everything's scaled as it should be to the numbers that are suitable for your environment, as well as making sure that it actually introduces that fabric management infrastructure layer that is outside of your production, so you have the tool sets to manage and monitor when things go down. And it's fully self-contained with lots of value added integration, enhancements and configuration that's done outside of the normal deployment. And then obviously we can break this down and have the same similar concepts across both the Azure Simple appliance, which as I mentioned concentrates more on the Virtual Machine Manager, Operations Manager and Orchestrator, as well as the Windows Azure pack, giving you that IIS fabric management layer. And also the integrated ITSM, giving you that more of a management service perspective, focusing on the users and your service catalog and your delivery. So I mentioned earlier how the PowerShell Deployment Toolkit doesn't replace some of the System Center components. So I thought it was going to be a good chance to sort of give you a real quick sneak peek into one of the main reasons why the CMA is so good and so successful in deploying all the System Center components. And that's because when we talked about what it doesn't replace, what the PDT doesn't replace, and that's the Virtual Machine Manager and the Service Templates capability. So let's have a quick look at that. So here we are with a freshly deployed CMA, and we can see that we're actually now in the Virtual Machine Manager console, and we can see the different tiers and the different services that we're actually utilizing to deploy out the CMA. So we have things broken down, and it's utilizing this idea of deployment templates within Service Manager that actually allows us to define out how the System Center components should be installed in what order, very similar to how the PowerShell Deployment Toolkit has that methodology around the installation of System Center. So does the CMA and the various appliances have that same methodology applied to it. But it means that we can deploy it out in this scalable fashion, so if we did want to actually add additional tiers to say like Service Manager for an extra one, we can just utilize the scale out functionalities to add extra tiers into it. But it also means that out of the box, all the different components are installed and configured with overrides set for things like management packs as our base defaults lines, applications within Configuration Manager ready to use and utilize. So the whole entire System Center solution is enhanced in the speed of delivery and the ability to utilize from the outset without having to wait to be able to actually then configure more post-integration steps for deployment utilization. So that's been a quick look at how the actual CMA is different from the PowerShell deployment toolkit, but again on how it extends the capability of delivering System Center in a matter of days through different solutions. Well, thank you very much for watching. Again, my name is Steve Beaumont, Cloud and Data Center MVP for System Center. You can obviously get hold of us within the UK at the Cloud OS community website and Twitter handles, and also you can keep up to date on the various UK MVPs with the hashtag UKMVPCloud. Please feel free to visit the various different URLs to either find out more about us at MVPs or just generally go and sign up for an Azure trial and benefit from the about £130 worth of credit that you currently get. So as a next step item, I do suggest you speak to managers and actually try and get in touch with Microsoft to arrange a Transform the Data Center workshop. So this is a half-day workshop that both Microsoft and partners deliver to help you start to dive into where the different aspects of the Cloud OS offerings can benefit you from an organizational perspective. Once again, thank you very much.